maybe I can give you some application areas where speech and communication or hearing aids is becoming the part of machine learning. So before just I give quickly introduction of speech and communication. So communication, the way we used to interact with others. So if you see the content of my presentation, it is like speech, communication and hearing aids. So how many ways we can communicate, the application of communication, and then I will directly coming to machine learning, and machine learning will be in the depth. Some supervised and unsupervised learning algorithm also will see. Then we'll check that how model evaluation and the selection taking the place, and finally some performance metrics like you heard about convergent metrics and other, we'll see in the terms of performance. So this is how human being used to produce through auditory or sound signals. Okay, whenever we used to communicate, so we used to produce some signals. Okay, there is some sensors by which we can capture signals, like we have microphone by which we are capturing the signals or sensor data, and which is again getting converted to electrical signals, and then further electrical signal by speaker or any other form of actuator which can translate again and which can play these signals. This is entire process. You are acquiring signal, converting to electrical signal, then taking the processing in this one, and at output you are getting again speakers. So speakers. So you are speaking on mic, that is like sensors which has captured the signals, it can get converted into electrical signal. After that, that electrical signal will play by speaker. Okay. So variety way in IoT, Internet of Things, is playing crucial role to control various things. Now you can see that drone also we can control through speech signals, through voice command. Okay, you can order anything in e-commerce side also through speech signals. So all of the platforms you are using, you are sending message, speaking something, controlling the IoT device like electricity, you are controlling also your car through connected car technology. Okay, various commanded which speech is playing the role. So how speech is generated? So there is microphone, okay, which is capturing the signals. The moment you are producing, so the signals is arrived, and finally you are using analog to digital converter. Okay, so you will read in depth once you will get dedicated session over the speech signal. So I am just giving you overview over machine learning, how we can overview. So in NLP, natural language processing, through voice we used to control various applications. So NLP, there is various areas like text generation, speech recognition, text translation. Okay. So suppose we have to recognize hello words. Okay. So first, the person has generated the signals, that is going through various filtering and amplification techniques. Okay, then ADC, analog to digital converter, has converted, and through network or internet, it is going over internet or cloud data is stored. Then there is techniques, pre-processing techniques which will remove the noise, you will extract the features, and then through machine learning you will recognize it. Okay. So what is speech signal? Speech signal is as emerged from a speaker's mouth, okay, nose or cheek, any of the forms. It is a one-dimensional function, and it is just air pressure. You can see that the diagram of the speech signal with respect to time. This is speech signals, and suppose the person has spoken hello words. That is signal for this one. There is speech, and you can see that different intensity of the signals is there. So this is what air pressure at the time. Microphone convert this fluctuation air pressure into electrical signal. Okay. So just sensor is not enough. Sensor will capture the things. There is processor, sensor, and again processor will combine themselves. Input transduction, which will convert one form of energy into another. Like here, what is happening? The moment you are speaking, the beat is coming from your mouth. That air pressure is detected by this microphone, and that is converted into electrical signal through microphone. So fluctuate air pressure into electrical signal and voltage or current. Any form, either it is signal or voltage or current and capacitance, any form of things is there. Because in IoT device, what is happening? Sensor is capturing something, and sensor will sense the change in the environment. Okay, whatever physical event is happening, that change will capture by sensor. That is converted into some other form of whether electrical signal, mechanical, optical, and any other form of signal. And again, that signal will play back so that human being can understand. So human being can understand speech, text, vision-based things also. Okay, so this is how we deal with speech signals that I do. So there is way of communication how human being used to communicate. Okay, so communication, as I told in morning, it is just not luxury to speak over other animals. We have God given choice to speak. We can interact with other people, but many of the people which having impaired of the sense of the communications, so they have another way of doing communication which includes sign language, that is not vocal language, that is gesture-based language. There is hearing aids. When people are becoming elderly, they are suffering with the hearing capability also. So they are losing this hearing power. So we require hearing aid, different kind of hearing aid is there. There is written form. The person who cannot hear, by written also we can explain gesture and speak now. So just to overview, this is what sign language. With this sign language we can identify or communicate with others. Okay. So this is language that use the visual manual modality. So there is two kind of modalities. One is visual, another is manual. That is modality means two different mode of communication we are combining together. Okay. To convey meaning in a state of spoken, the person who cannot speak, okay, who is have that problem in the speaking, they can communicate through sign language. You can see that variety of sign languages by the signal you can understand. You can have all alphabets by the hand gestures you can write it. The sign language are full-fledged natural language. So you see that the challenge with the natural language is very much. If you see simple programming language, this is called high-level language, okay, which is converted through compiler to low-level language. But in natural language, the way we are speaking, whether you are speaking combination of Hindi, Kannada, or Hindi, English, and in this way, the machine has to understand. So it's not like ordinary, like we are programming language, we have fixed set of dictionary, we have fixed set of grammars. It is very complex because there is accent is different, mode is different. We are using combination of different languages. Okay, so these challenges are dealing. So sign language is also considered full-fledged natural language, okay, with their own grammar and lexicons. So the for natural language, it is must that there should be a set of grammars and lexicon. Lexicon means a small token which can be recognized as a word. That's those the challenge with sign language, it is not universal. Each country they have its own standards. You go front, tense, then they will have their own set of, for Semwal, hello, they will have own gestures. Okay, so they are usually not mutually intelligible. Although there are also similarity among different sign language. Okay. So these are some sign languages which Institute of Statistical ISI Kolkata has developed the big data set over this one. So 1, 2, 3, 4, that is very simple gesture, ABCD for alphabets. Other gestures, there is different side. So like you can see, you are going for bathroom, board, hello, help, no. All sort of gestures will be communicated by hand movements. Okay. So this is one way of communication when you are speaking impairment. The person who cannot speak, they can use this mode of communication. There is another thing which is very important by folks also. In this case, it is just not some static gestures. These are the dynamic gestures. Dynamic gestures, in which you see that there are 5 hand gestures, pushing and pulling. The first one is when I am pushing and pulling, by which you can understand. Second one is waving left and right. Third one is up and down. Fourth one is stretching the each fingers. These are considered as dynamic gestures. And in robotics or designing of artificial hands, robotic hands, these gestures are very important. That time, the person who is suffering without hand, this mode of communication will help. Okay, for measuring this one, you require force sensor also. How much magnitude of force we have. So I will acquire the speech signals. Already we have told that we have a vocal code by which we are going to record this one. But I am not doing anatomy as well as physiological aspects of ear and vocal cords. But I am just defining how to capture. So we have multiple sensors by which we can capture the signals. Okay, we require sensors, otherwise we will not able to capture the things. Okay. So vibration acquisition, as I told, there is air pressure which is generating, that will be captured. Okay. So machine learning, what machine learning can play a role? One is data. We can apply some high pass filter to understand. We can use neural models, the brain signal, and recognize the output with the speaker. We can identify the person by the speaking. It is like as a biometric identification. Voice also considers many times. That is also unique. So there is some signals with the help of laser is represented for certain words like bathroom, curtain, sun, so on. So anytime you can get that the speech signals we are recording. Now coming on hearing aid, and then we start machine. So hearing aid is a small electronic device that you wear in or behind your ear. Okay? It makes some sound louder so that person can hear perfectly. Okay? And communicate and participate in the discussion area. So there is some different kind of hearing aids available so far. Inside the ear, in the canal, receiver in the canals, and you can put behind the ear also. Some machine learning projects in which we are dealing with signals. Already I told that interactive communication is required for when you are going to control some devices. Drone you can control through voice signal, that time you are using. We can recognize the speaker. Okay, so one exercise does not exist. Navigation on Mars. Okay, so you can what you can do, you can record the voice and you can send over the Mars. The command will understand by the rovers or robot and will move here and there. Okay, because human being cannot reach on Mars. Okay, human cannot explain their expertise. Okay, so how will you understand that what is the expertise of human based on whatever speech he or she is delivering. Okay, model must be customized. Okay, personalized medicine. So person who is taking daily medicine, that time also we require some help, and we can use some speech signal also, like alert system. So already I discussed this model. Okay, there is some challenge. Okay, which we have to deal. First, we have to minimize the background noise. So whenever we are designing the devices, they are suffering with the background noise. Okay, so noise removal techniques are there with the modern algorithm you have. Person require face-to-face communication for better. That time modern language kind of things is there where you can communicate with the robot, with this laptop also, with the visual interaction or communication with it. Then you have to rephrase. Many times the sentences are not correctly interpreted by the machine or computer. That time you have to rephrase. You require grammar correction and other things. You have to summarize some quotations. These are all part of nature language process. So already I introduced sensors. Sensors works like this. So sensor to capture the input signal. With the help of output mixer, sensor plus processor, it is becoming input transducer. Input transducer is converting this air pressure into electrical signal. And then electrical signal is further interpreted and play in the output words with the help of processor plus actuator. That is in our case is speaker. Okay. So transducer is nothing but is convert one form of physical signal into another form. In our case, microphone converts sound to electrical signal and speaker converts electrical to sound. So there's another example I am not considering. So already I told the application of machine learning in the area speech enhancement and noise reduction, automatically speech recognition, speaker recognition and adaptation, and real-time language translation. So coming back to machine learning, that is very important, which I was going to cover today. Okay. So machine learning where the main ingredient is the data. So data could be in any form, numerical data, your speech signals, your image files, textual data, audio data, and various other form of sensor data. So the device which will capture this data is sensors. Like human being has certain sensors, visual sensors, audio sensors, touch sensors, body sensor, inside body also we have, which can measure the pressure also and force and pain. Okay. So once you have data, then you can train the model. Okay. So for training models, we require huge amount of data, but it is different variety of data is required. That is main ingredient for training the models. So first we will prepare the model. Once model is prepared, then you will check whether how my model has learned. Okay. So many times what is happening during model prediction or model learning process also our model is not or going to suffer with certain problems which I will deal with after 3-4 slides. Okay. So generally we used to divide data into training data and casting. Okay. So training data to train the model. Suppose I am considering the example of speaker recognition. I need to identify who has spoken these words. Okay. So for this we record a speech signal at least 5 or 10 times. Okay. Different word and sentence we will record, and based on this one we will predict the model. And once model is predicted, then based on testing data, we will test how good our my model, how accurately we are going to classify this. So if you see those who are from computer science, they can understand in traditional programming and what is different in machine learning. In traditional programming, the set of instruction or program or algo is given and data is input. So with the help of data, suppose I need to sort the number in the increasing order 1, 2, 3. So suppose reverse order number is given. You require fixed set of code and you will get fixed output. Okay, either it is correct or not, that is different, but you will get output. So that is what traditional programming. But in machine learning, you are given data and output. There is no algo is given. Program will itself learn through the given data. What is the pattern available over data? Suppose we are listening to a doctor and we are going to check. Doctor is going to take your BP and temperature, and based on this one, the doctor is deciding whether the person is healthy or not. So, if data is coming, generally we are observing if temperature is more than 98 degree Fahrenheit and BP is also more than 90, the person is having the fever. Otherwise, it is healthy. So, this kind of classification we are running on through machine learning. That's why the data is very important. So, broadly we classify machine learning into supervised and unsupervised categories. Okay. In supervised, we have given data and output level. Okay, the level is known before. That's why machine learning techniques little bit tedious, because we need to craft the handcrafted feature and we need to provide the level. If there is no level, then we have to go for another mode of techniques that is called unsupervised learning. So you have given input data and corresponding levels are given. Suppose I have 2 parameters, one is BP, another temperature, I am recording another patients. So each patient data in front of this one I am writing the class, whether it is healthy and if it is binary classification. So 0 and 1 or -1 and +1, this kind of data we need to provide. So here in supervised learning we have given the input samples that call measurements, attributes, features. It's like in our model for this one which I have taken example in BP and temperature is my feature. So it's 2-dimension data. I will represent 2 dimensions. You can have 3 dimension, 4 dimension, n dimension of data. So this is like column. Okay. And the volume of data maybe we have taken the 100 samples, 100% data we have collected. Okay. And then corresponding output level is. In machine learning, what we are doing, we are just converting or mapping or trying to design this mathematical function x, fx, whether it is sinusoidal function or some cubic square relation, which is trying to build the relation between x and y. Okay, so y is your output level, which is your, in case our binary classification, healthy and unhealthy, and x is your input features, input data, which having 2, 3 dimensions and maybe 100 samples. Okay, so my objective based on this input and output data, we have to establish the function f. This is mathematical function. Okay, and we call machine learning as a approximation. Neural network is also considered as an approximator. The reason is that we are not going to map exactly. Okay, we are just going to map approximation based. In supervised, the training data is accommodated by the level and indicate the class of observation, and y is your discrete class. It is not continuous data like through sensor and continuously recording the data of temperature and mood. This is continuous data. Discrete data, whether like binary classification, ternary classification, and so on. So supervised learning divided into 2. One is classification, another is regression. Regression is called prediction model, where the y is continuous, and if y is discrete, you can discretize, then it is classification. Okay. The another form of things is coming unsupervised because the data is very huge and it is generated randomly. So in this case, what is happening? Maybe we are not aware of y level of each data. So based on their similar characteristics, I will try to accommodate or group the data to them. Okay. So in this case, when the level of y is not known for data x, then it is called unsupervised. Okay. So the example of unsupervised is clustering. So again, clustering could be two classes, three classes. Based on this, we will classify the data. So that is called clustering technique. And if y is continuous, like in previous case, y is continuous, I was giving the term regression. So I will tell unsupervised neural network. So you can see the sample of data. And there is some data is given. There is given ID, then refined status, marital status, and taxable income. So you see that some numerical data, we have some textual data where you are taking, and you see that different is binary, either yes and no. Marital status single, married, divorce, and 3. So the marital status can take 3 values: single, married, divorce. Refund status, whether you have refunded money or not, that is yes and no. Taxable income, we are going to check. So this is like continuous data is coming, which is not binary or ternary. These are discrete data, this is continuous data. So how much taxable income you have? Based on this, we have to check whether person is cheating or not, or whether bank will provide you loan or not. So for this we have to see. If you see that you have cheated classes, again binary classification, yes and no. So if you see the yes sample, so you see that the person has no refund history, the status is divorce, and taxable income is 95K. Okay. Then person is going to cheat it. Okay. Either when person is going to cheat, person is single, refund status is no, and you can see that if salary or taxable income is 95K, less than 95K, and person is single and divorced, so it is coming in which category of yes category. This yes category also single and yes. So single and divorced. If person is married, so generally they are coming in the no category. So based on this, we have to design some mathematical model. This is just sample data I am collecting. This is what supervised learning. The label is given. For each sample, the class label is given. I need to decide whether person is cheating or not. Then you can apply any sort of machine learning algorithm. Like here you have decision tree, you have classification, anomaly detection, you have some association bindings, you have clustering techniques. So in decision tree, what is happening? First we are classifying based on income. Income is less than 30K, income is between 30K and 70. Then we are seeing that person is marital status is married and single. If married, then I am going to directly approve loan because he is not going to cheat. But in case of single or divorce, I will check another attribute, that is refund status also. Okay. So I cannot draw. Maybe in next slide I will have some decision tree example. That time I can explain. So the core thing is that in machine learning you require data. Okay. Then different sort of algorithm is given. So in predictive modeling, you can take this example also. Employees, level of education, year of at present address, and credit worthy. Okay. So find a model for class attribute as a function of the value of other attributes. Okay. Here also we have binary classes, credit worthy and no. Whether the person, if you give, it is worthy or not. So you can see yes and no. So what here first they are taking, person is employed or not. So there is two output, either yes and no. So the branching factor will be 2. This is decision tree models. How machine learning model you can employ over data, you can see. So we have yes and no. If it is no, you can see that there is only no. So you are not credit worthy, you are directly reaching to conclusion, you will not further explore. Because there is only one attribute is sufficient to decide for no. But in case of yes, we have to see the other attribute also. Okay? Because so in case of yes, I am going to check further education. If education is high school education, graduate and undergraduate. So if you see that graduate and high school, then it is yes. If it is high school, then no. So again we have graduate person and number of year of experience. If experience is more than 3, then yes. If experience is less than 3, then no. Similarly, you can go high school and undergraduate, then further I am going to see year of experience. So these are attributes, and the height or size of this tree can be different. Different people can interact with the different tree. Suppose you have considered first, you are going to check level of application. Then the tree will become different. Okay? And it out in this case, you are understanding this in decision tree. I am trying to form the decision. I am selecting which attribute which is more doing distinction between data. So when trying to fit that attribute on the top, then second attribute, third. If there is still ambiguity, then I will explore further. So if there is no ambiguity, I will stop. As in the case of no, I will not further explore. Otherwise, if employed, the status is low and I am not getting clear classification, I will put education or number of year. You can put number of year above than education. Then also you can construct that. So this is the case of decision tree predictive model. Okay. So already I given you example. Employee is the categorical data which we call binary classification or discrete data. Level of education also discrete. There is 3 level of education: graduate, high school, undergraduate, and then that is quantitative and continuous data, and the class level is given. So from there, once data is there, level is known, you will try to turn that is considered training data set. Then you will try to learn the classifier. In our case, suppose I have used in previous example what decision tree. You can go for neural network, you can go for SPM, you can go for any mode of machine learning algorithm. Once model is designed, then based on test, we have to classify. Now, suppose the data is given, the person is employed, the level of undergraduate, year of experience is 7. Then, what will be the credit worthy? Whether it will be yes and no. So, I will decide. You just need to explore this previous tree. So, person is employed, yes. Education, undergraduate, and year of experience is 7. So more than 7, we are going, our attribute level will be yes. In our case, we are doing manually. Similarly, we will perform by machine. Okay. So similarly, you can go for when employee level no, undergraduate level of education. So if employee level no, you will not further explore. The credit worthy level will be no. So with one level of abstraction, you can represent the class levels. Okay. So already I told that classification versus numerical prediction, which we refer as regression. In classification, predict the categorical class level like discrete or nominal. Whereas in case of numerical prediction, you have regression model where you are getting continuous values. Okay. The some application, credit and non-approval. Medical diagnosis, if person is suffering in cancer or not, I will take example in commensurate of both credit non-approval and tumor size. Fraud detection, okay. Web-based classification, whether it is spam page or it is genuine page, spam detection, okay, filters where. Other example of machine learning algorithm which you can apply is classification credit card transaction, whether it is legitimate or product, classification of land covers, water bodies, urban areas, forest cities using satellite images. So you see that different form of data we are considering. In first form we are considering numerical data, second form we are taking the satellite images. Category is the news story finance where we have weather, entertainment story. So this how you represent the data in machine learning. Okay. So consider attributes, categorical and numerical data. Already I explained, so I am not going to explain further. This is some example of the data. Okay. Again, I am not doing this depth. Okay. This I will skip. Coming back to supervised learning. And with this example, you can understand the attributes and features. Okay. So you see that there is two levels, the data x1 and y, x2 and y. All data sample is associated with one level, y1 and y2, y3. y1 is what? Class level. Okay. So x1 could be which dimension data? It could be 2 dimension, 3 dimension. Inside x1 you can have, in our example, suppose x1 is the RAM. So they have BP, temperature, blood samples, blood group, and these kinds. So we have 4 data. So the dimension of data is depend on how many attributes you have in case of x1. So in previous example, you can consider like suppose this is x1, this is x2, x3, x4. The dimension of this data is what? 4 dimension. 1, 2, 3, 4. X is 4 dimension data. The output y is only 2 classes, yes and no. So binary classification. Total number of sample 10. So similarly you have n class vehicle, n samples x1 to x1. Maybe the dimension will be there, and the y's will depend on how many class levels we have. So in your example you see that the tumor size, the cancer size is there, and we have to check it is benign or malignant. Based on size, you are deciding the cancer is benign or malignant. So this is what one dimension data. Only what you are considering tumor size. X1 is what? Tumor size. Person Ram, Syama, Sita, Gita, and this one, and based on this I am deciding. And then I will classify into 2 categories. Y is 2 levels, either malignant and also benign. Okay. So you see that after if size is little bit greater of tumor, so I am classifying this as benign as well as malignant. But if size is very huge, I am considering malignant. But this cannot be true. Maybe the standard thing that if you consider the how long this size, year also you consider. It is from 3 year, 4 year. If it is in early stage and size is big, then like the person is suffering with the cancer. Okay. So maybe this model which I am designing is not true. So we need to consider more attributes. More attribute means more dimension. X dimension, Y dimension, Z you can go for N dimension. Okay. So what I did? This is I am representing to binary classification in 2 dimension. Same data I have converted into 1 dimension. Okay. So classify data into 2 dimension. I can have some line. Okay. In n-1 dimension plan, if it is going more than 3 dimension data, then we can have maximum 2 dimension plan to separate the data. In case of this one, you can draw one line. By line, you can classify the data. And you can have variety of line. How good your model is done, it will give you better prediction. Okay, classification. If you are projecting this data over 1 dimension, that means only one axis is there in tumor side, then you are using what? Dot. So if data is of 1 dimension, so you can use maximum which dimension data, and -1 means, and 1 minus 1 is 0 dimension data. And 0 is that means it will have at least direction. It is 2 dimension data. You can increase number of features. Now what I am considering, one is tumor size, another age. So it will be better predict that. If age is also more and tumor size is bigger, then I am considering them as a malignant cancer. If tumor size is big but age is less, in this case you see that tumor size is big but age is less, it is an initial state, so I will not consider it as a malignant, I will consider it benign. So this model is better than this model. If you include number of features, apart from age you can see that clump thickness, uniformity of cell size, uniformity of the cell shape. So maybe you can go 3 dimension, 4 dimension, 5 dimension, then you will get better prediction of models. Okay. So X can be multi-dimension, each dimension corresponds to attribute. In this case, I have 2 dimension data, in this case I have only 1 dimension data, those output is labeled in different form. If you include clump thickness, it will become 3 dimension data, then 4 dimension, 5 dimension, you can go N dimension data. In case of unsupervised, the label is not known, that's why there is no color is there. As in previous case, you are seeing that we are giving that blue dot is for benign and red dot for malignant cancer. But in case of unsupervised learning, the label is not known. Only suppose this is your tumor size and this is age. Based on similarity, I am trying to categorize into group. Okay. So these all 4 are coming together. These 4 are together. These 4. Based on this, I can classify. You can increase in 3 dimensions for better projection of data. You can go for 4 dimensions, you can increase the number of dimensions, but once you are going for more dimensions, your computational cost is increasing. Okay. So in this case, the label is not associated with this axon. Just sample is given without classes. So output hidden structure behind the is X, that is called clustering. So finding group of each object. So there is multiple clustering techniques. One among is nearest neighbor classification. Based on the similar features, we try to classify the new samples. So suppose there is training records, okay, and the new sample is coming down. To whom it is very near to. See, so we have we will compare based on their features. Okay, so we have computing distance. So which is the nearest one? We'll select this one. Okay, we'll select, choose the k from the nearest one, and then modality weight both is there. If out of 2, both are belonging to sand labels, so we have categorized this is coming with the water surface table. Okay, this is k based on the features. This is just distance I am calculating. Similarly, you have another technique that is called k neighbors, KNN techniques, k nearest neighbors and KNN. This is already told. You can have large scale data also when you are going for surveying purpose, satellite data, sensor data, cyber security. You can have huge volume of data. Okay. So there has been an enormous growth of data. Then manually you cannot classify. You require some automated tools, some machine learning or AI enabled tools in this case to classify the data. You see that data would be any sort of form. You can have social networking data in Facebook. We can see that who is connected to your mutual friends, friend to friends. Based on this one, we will try to trace your network or try to recognize. Now coming on how to design the model and how to consider the model is perfectly designed. That is very important because many times what is happening, the model is suffering with the overfitting or underfitting. Those you have trained model with a sufficient amount of data, but what will happen, your model will not perform accurately over unknown data. With the training data it will perform better, but unknown data it will not perform. That is we call model fitting and model selection. Which model is accurately given. So for model construction you require the data, okay, and you have class level also associated. You will split into training set as well as testing set. So training maybe you consider the 60% of data, 20% you can put for validation and 20% you can put for testing. So validation is also very important because how good my model is learning, that you can calculate through validation data set. During training, how good my model, because validation data set will always important during training, and after that you can test. Okay, and if model is overfitted with the validation data set, we can see that the performance is going down. We can easily stop it. After some time, I will show some curve by which maybe I have some curve by which we can explain better to this one. This is somewhat referred as bias variance trade-off. Okay. What is happening in this case? You see, this is especially for model selection, and which model is perfect, that I need to decide. Okay. So what we are doing? The moment we are increasing the complexity of model, suppose initially I am using one order of polynomial, second order, third order, and we are going up to 8 order of polynomials. Okay. So this is perfect that we can match with the 8 order of polynomials with the data. This is very important to understand for model selection. You see that we have given some data, some random samples. We have 1, 2, 3, 4. These are the samples. Let us assume these are 100 patient data. Okay. This is x-axis, y-axis, 2-dimensional data. And I can fit multiple models. I can put the equation of line here. I can put x square, I can put x cube, and I can go for more complex 5 orders of polynomials. You see that 5 1, 2, 3, 5 orders. You can put any sort of models. What will happen? It will increase the complexity of model, you can go for this high order, this blue color model. You are able to map training data very nicely. The pattern you are able to capture is very nicely. But we know that data inherently coming with some noise. Because these are sensor data, it is coming noise. The moment you are trying to capture this pattern, you are learning noise also. Your model is learning noise. So for training it will perform better. Suppose future data is coming here, maybe it will not perform better. Okay, this model. This is what we call overfitting. When you have selected very complex model, performing well over the training data, but unknown data, maybe it is coming here, my model is moving from here. That time my model will not able to capture that pattern. So this is called overfitting. That means model is trained with the higher order of polynomial equations, complex model, and it's suffering during testing. This is called overfitting. If you will take very ordinary line, very low complexity model, so then training as well as testing error will be more. You see that actual models data is here and training model is here. You see that there is gap. We call this is error. This is my actual data and this is my predicted data. Actual data, predicted data. This is model prediction. Okay. If you are increasing 2 order polynomial, little bit error is less. If you are going for n order polynomials or 4 order, 5 order polynomials, you see that almost data points are lying over this model. That means there is very less error. The gap is very less. Understanding this point, this is very important in model selection in machine learning based on data samples. So this is called high bias. When you have too much error, you have selected very basic model like equation of line, so there is too much gap, it's called high bias. When you are selecting complex model, we call variance. That means if there is too much complex model is there, so two model cannot be same, variance will be there. Okay. So that's why the term bias variance trade-off is coming important. Model with the too few parameters are inaccurate in our case on the equation of line because lot of error is there. It is not able to match the pattern of input data because of large bias, not enough flexibility. But if you are taking model with the too many parameters, complex model, accuracy becomes the large, that means it's called large variance, too much sensitive over the data points. It is trying to match all data points and that to be these points can have noise. So I am trying to have noise also. Due to this, what will happen? In testing data, maybe my accuracy will drastically fall. So you see that this example, the expected mean square error values, noise square, bias square and variance. Noise I cannot deal. This is unavoidable because this is with the sensor, but I can deal with bias and variance. And bias and variance you can deal with the selection of model. If model has high bias, what I will do? That means there is more errors. I will try to go for more complex model. So bias will become less. But once you go for more complex model, variance will increase. So I need to do trade-off between them. That's why validation data set is important. At which point I need to stop. At which point I need to stop the selection of model. So that the model should not get overfitted or underfitted. So example, you can say that this blue line is showing standing error. Initially, the model complexity is very less. When model complexity is very less, that means there is high bias and low variance. Model is very simple equation of line. Suppose you are going for complex model, 9 order, 10 order of polynomials, the variance is increasing. Model becomes complex, but bias is less. So what is happening during training? Initial error was more. And what is my objective? I want to try to minimize the error. And what is this error? Predicted data and actual data. So which model you select where my prediction should be correct, very close to accurate data. If there is gap, but initially the gap is more, I started selecting the complex model and training data almost become 0. Okay. So maybe I am going further, I can extend, I can go increase the complexity of model and training error ideally will become 0. But what will happen? Is testing error is also reducing in same fashion. So initially you have high training error and high testing. That is okay because model was simple. But here ideally the error becomes 0 and after certain point the testing error becomes more, the gap is going to become larger. So you have to stop at this point. So who will tell us? Validation. So instead of testing error, we will check the validation error. The moment validation data started moving some other, the gap started increasing. That means model got overfitted. That means too much noise has matched by the training sample. So it has perfectly matched training data, but for testing data, it is giving wrong prediction. Clear? So where you will stop is this point. So there is multiple techniques by which we can deal with this situation. One is early stopping. We continuously monitoring the validation error and training error. The moment gap is constant or it is decreasing, I am increasing the model complexity. The moment gap is going to increase, I will immediately stop and select that model. So that model should not get overfitted. So this section called underfitting, this section called overfitting. Underfitting, okay, if I am not taught you well, you will not perform well, I am expecting. But if I am teaching you very well, but with one example, so maybe in exam you will not able to perform well because another example is coming. Because you are learned with the one ergo 10 times. So you have no generalization capability kind of thing, that's why you are not performing well. That is poor performance. Okay. So this portion called underfitting, this called overfitting. To avoid underfitting, we can increase model complexity, and to avoid overfitting, I can decrease the model complexity. Okay. This is same example, test error. Earlier it was training error, a test error comparison was here, but now test error. So what is happening in training example and many training examples? Okay. So in case of initially the training error mode, testing error mode, but from this point onwards, what is happening? The training example is reducing and here it is increasing. So I will stop at some points. This is called early stopping. So coming back to my discussion on decision tree, model selection was very important in machine learning. That's why I explained you before going on. This I am not going to tell you right now. Okay. So now general approach for building the classification from machine learning model. The data is given. Based on this one, the learning algorithm you will take. Based on this learning algorithm, we will learn over this data and your model will predict. Okay. This is called training model. To test, we require the further testing set. With this, we will evaluate the performance of model. Now question is coming, how you will evaluate if my model is how much % accurate, and what are these parameters by which you can check the model performance. So one is accuracy, you heard about accuracy, precision, recall, F score, what are these? So I am directly switching over there. Okay. Because we'll have very less time to come back to this one. Coming on model level, one is model selection, which I already covered, how to select model. Okay. Now coming on model evaluation. If model is designed, how good my model has done. Before this, we have to do some basic practice because we want generalized model. We don't want too specific model. If one ergo is performing very good for one ergo, but if similar ergo is coming, that time my model is not performing better. That means there is no generalizing capability. My guess is very biased. We can say that biased. So for this, there is one technique that called cross validation. So always divide your data into training set, validation set, and testing set. Now you understand the importance of validation because whatever done by the testing, that can be done by the validation set. Okay. So validation is continuously running over your model. Once your model is training, that time you will get validation error and validation accuracy. Okay. So we have cross-validation techniques where we use two parts, divide the data into case set or 5 set. If you have three set cross-validation, I will divide the entire training data into 3 parts. And then randomly I will select at a time one part as a testing sample, next time second part and third. Because stability of model is very important. Maybe for one test set, my data is performing 98% accuracy, and I change my test data, and then it is giving 67. That I cannot accept. Almost it should perform consistently. Like if it is giving 97, 96, that is called stability of model. That's why whenever you are testing, it is not you test with a single set of data. You keep changing this data set. For this we have these techniques. Like in 3-4 cross validation, the data is divided into 3 portions. Suppose we have 100 samples or 90 samples, I am dividing into 30, 30, 30. In first time I am using this first 30 sample as testing, these two as training. Second time I am considering this as for testing, and this first and third is for training. So each time I will training my training and as well as testing set. So with this I can prove that my model is stable. Because it is not that if you are with this configuration my data set is giving 98 accuracy, with this configuration my data set is giving 67, with this configuration my data set is giving 85. Then model is not stable. It should give almost near 97, 96, 95. Okay, that's why before performing classification we used to perform the cross validation. Okay, because what is happening, sometimes what will happen, with this model is getting overfitted and you are getting 98% accuracy. Second time you are getting 67%. Third time you are getting 87%. This could be the reason due to the imbalanced data. Imbalanced data is like that. In first class, what is happening? This data belongs to class 1, this data is belonging to class 3, and this is class 4. So in this case, during training, this data will perfectly able to classify class 1 data. But if class 2 data is coming, then it will not able to classify. So that's why cross validation is always required. Models should learn with the all set of data. Now coming on the first important matrix by which we will check the performance of model. This is called confusion matrix. Very simple to understand. Okay. So there is actual class level and there is predicted class level. And why it is required? Why other forming parameter is required? Precision report. If accuracy is okay, why we are doing? When data is imbalanced, one class data is 90%, another class data is only 10%. Like you are going for pass or fail students, so mostly students will get pass, very less students will have less than 30% grade. So these are very minority data. What will happen in this case? The majority class will subsume and will suppress the data of minority class, and your model will get overfitted. Getting points? In this case, majority class is going to lead over the minority class. That's why overfitting is happening. So either you can go for synthetic data, you can balance both the classes 50-50% you can do. You can reduce the majority class data and you can increase the sampling minority class by duplicating of data. That's why we require other performance methods. Many times what is happening, you are getting accuracy 90, but precision is only 90, not 90 also 80. So in this case, you will not select that model. Okay. So first let us take example. Suppose person diagnosed cancer and no. Class yes is if you are suffering with cancer, class no is if you are not suffering with cancer, and predicted model. If person is having cancer, diagnosed cancer, this is called true positive. And that is true. No problem. Person is suffering with cancer and diagnosed no. That is very dangerous. This is called false negative. Okay. In this case, we will not able to start the treatment and we will get delayed. We have to go further. There is no cancer and diagnosed cancer is still okay. We will get unnecessary treatments, maybe side effect, but it is not dangerous. No cancer and so this is true negative and true negative positive. These two classes are important for accuracy. If person having cancer, diagnosed cancer okay. If no cancer and diagnosed no cancer, that means model has worked properly. But if there was no cancer, diagnosed cancer, if cancer and not diagnosed not cancer, that is little bit problem kind of things. Okay. That's why we consider all 4 parameters to calculate for the matrix. So accuracy will define based on A plus B upon A, B, C, D. Accuracy is what? How much truly classified क्या था cancer, diagnosed as cancer, not cancer and diagnosed as not cancer. This is called properly classification over total samples. Total sample are A, B, C, D. Okay, so A plus D upon A, B, C, D called accuracy. But I told that accuracy is always not correct measure when data is imbalanced. We must check other performance measures also. So just this point you remember what is true positive, true negative, sorry false negative, false positive and false negative. That means there was no cancer and diagnosed cancer, it is called false positive. There was cancer and detected no cancer, it is called false negative. So what is accuracy you can read from here, and that is the widely used performance matrix of model A plus B upon A, B, C, D, that means true positive and true negative over false positive and false negative. Nothing special, because this is quite confusing term which we use to refer during performance evaluation of model. So example is given here. So consider the two class problem. In one class you send we have collected the sample for cancer patient data. So out of 1000, 990 was no cancer, only 10% diagnosed the cancer. You see that there is huge disbalance or imbalance between data. Correct? No class having 99 sample and yes class having only 10 sample. What will happen? If you design any of the machine learning model, this class will subsume this class will leave. Okay, no class will suppress the yes class data. Even though cancer is there, it will show there is no cancer. Because most of the time, if I am a doctor, always healthy patients are visiting. So I am having poor guess about unhealthy patients. Getting? So that's in the case. Even though the patient is coming with some abnormality, I will tell no, this is common sense. Because I am not having this much of experience, because I am having very less samples regarding this class. So this is what called imbalanced data set. In this case, how much accuracy I am getting? You see that example. This is my detailed model through machine learning. This is my actual data. So class yes and class is 0 diagnosed. Class yes and class no only 10 samples. Class no. So if you take the accuracy is what? 0 plus 990 divided by 1000. Okay? So I am getting how much? 99% accuracy. But you see that here it has misclassified all the 10 data of minority class. So how we can say that this is good class? Because this 10 should come here. There is cancer, it should diagnose cancer. There is cancer, it is diagnosing no cancer. All 10 samples. Due to overfitting. That's why I told that accuracy is only not measured. If accuracy will consider, you say that 99% very good accuracy, we should accept this model. But this model has performed very poor for cancer patient data. When they are diagnosed, yes. It has classified them also the no, because it has suppressed this data. And it is having very less experience of yes data, so it has classified all negative. That is very dangerous thing. That's why we used to go for other measure also, precision, recall, F score, R score, whatever scores are there. That we also. This thing is misleading because the trivial model does not detect any yes samples. And detecting the rare class is usually more interesting. And you will find most of the data where you will find binary classification, and one class will get 997, another is 10, like fraud. Very rare chances in getting frauds. Yes, smart detection in your mobile phones and somewhere, worm, intrusion detection. Defect in computer, out of 10, only 1 or 2 computer will be detected as 99 or 98 computer is correctly received. So this kind of data will receive, and that time accuracy is not measured.
This kind of a scenario is basically with respect to the data type of a model. This kind of a scenario, most probably.
Mostly real time you will get such kind of data. Always you will not get balanced data. Okay, 50-50 both class will not get, because the cancer is very rare. Okay, similarly the malware detection very rare you will get the chance in your computer. So due to this model is learning, due to the nature of data. Because what model has done? Model has already ignored this class.
So we need to take thought in terms of.
That's why always we used to check before designing model, we used to balance the data. We used to generate synthetic data. Those is duplicate data, but we try to make 60-40, 50-50, 45-55, 55 kind of data. At least we require both proportional this way. If it is going less than 20% for one class, another for 80, then again model will suffer. Okay. And in this case, you will not get good performance because for this accuracy 99, precision you will get maybe 40 because you will get very less. So such model will not be done. Before applying model over this one, we have to balance the data. So this is due to the data. This is not problem with model. This is due to the problem of imbalance of data. Now coming, which model is better? Can you guess what is the accuracy of this model? 50. And what is the accuracy? But it has classified all 10 negative. Here, 10 they have classified correctly. Maybe misclassified on this level. There was no cancer, diagnosed cancer. That means it is called false negative. Okay. But it is almost giving for 90% correctly plus 10. So this model is better compared to this one. Okay. Because this model has not ignored these 10 samples. Though it is very less insignificant sample, still this model has considered. So I will prefer model B over model A.
So imbalance data is due to the size of the data set?
It is in nature like suppose I am considering the how many times I have purchased handheld computer. So out of handheld, it is very rare chance that you will get defective computer 2 or 3. So in real time you will always get like this. Even though you are visiting to doctor 90% time, you will not be suffering with the COVID or something, 10% only. So this is due to the nature.
No, I'm asking, is it due to the size of the data set? Is it less this data set size?
Maybe
There is
yes,
chance
yes,
of getting
data-
imbalance.
yeah, obviously,
Or if it's
obviously.
more data set.
Okay.
It depends on the number of samples per class. If in one class there are thousands of samples and in another class there are only 10 samples,
samples.
then it is called as
Some question is
imbalance
that
data
due
set.
to the less sample, if you will increase, maybe you will get this ratio more.
If
This
number
time.
of samples are same in all the classes, then it is called balance.
Here it is 1,000 samples are there.
If I increase by 2,000, maybe I will get 30%.
Okay.
That is depend on this one. And there is one solution. If we can increase number of samples.
So if number
That's
of
why
samples-
whenever we talk about big data, it is not size of data, it is variety of data. We require what variety of data. Size you can get in one sample. In big data we have
in
3B varieties, 3B like
one bigger data set also there is a chance of imbalance.
You can always balance the data using many
Correct,
techniques.
correct.
So data augmentation you can do.
Data augmentation technique, and we have some testing also on forwarding. Synthesized data you can generate. Oversampling, undersampling. By oversampling, you can increase the minority class data to up to higher class, and you can reduce also upper class. So here if you see the accuracy again, you are getting higher accuracy here, low accuracy is below, but still my model is better compared to it. Correct? B is better still, because it is for negative class, it is not going to be. Now coming on other measures, this is precision and recall. And average score. Average score is nothing but geometrical mean of precision and recall. Okay? So having same impact. So precision is what? True positive upon. You can see that. Person having cancer, diagnosed cancer, it is okay. This is precision. Person having no cancer, diagnosed as cancer, that is false. So how many positive classes we have achieved? Okay? How many positive cases we have diagnosed? Where we are getting detected cancer. So this is recorded by the precision. Okay? So precision is going on this vertical plane, and horizontal plane we are going to see record. And then you can go for, generally you see that in paper they will not write precision record, they will write average score. Average score is nothing but this is geometrical progression of precision record. So already they are conceived. Okay. Now see what this example, which I consider this classical example of imbalanced data set. The accuracy I was achieving almost 99%, but precision 50% recall the value of 1, and the average score is getting 62%. Huge gap. This model you cannot select. So if you are not calculating precision recall, just you are checking accuracy, maybe you are wrong. That's why these major F score always considered during the accuracy. For another case, accuracy is again 99. Okay, the precision is 1, recall is coming only 10%, F score is 18%. Again, this model is not a good model. Similarly, as I given the example of cancer classes, similarly you can have a defect in computer also, or malware detection in your computer systems. Most of the time you will not get, but very rare chance you will get. Okay. So I am not going in this discussion already here. Other major are sensitivity, specificity, okay, accuracy, precision recall. Precision recall is combined by the F1 score. Sensitivity, specificity is also there. Okay. Coming back to my discussion, one is model selection, another model evaluation, and now how mathematical we are modeling the model samples and which model we select. What is the how you can increase the accuracy? As told you can increase number of samples. That is also true. So you see that in this case we have how many dimension data? 2 dimension data. One is x-axis, another is y-axis. Okay. And you have how many class level? 2 class level. One is oval shape, another is x-shape. How many samples? You can count 20 here and 10 here. 30 samples almost we have. Okay. This is balanced data set. Almost both class having equal amount of data. Okay. Now my objective to learn this mathematical model, which machine learning algorithm we have. Which equation of in 2D I can draw equation of line. In 3D I can have 2D plane. In 4D we can have 3D plane. That is called linearly separable data. This data is linearly separable. If it is 1D, I can put the dot. You know, so this is linearly separable data. In case of non-linearly separable data, where in 2D with the help of equation of line, if I am not able to separate the data, if data is some zigzag, I will have the pattern of data. You see that there is positive sample, negative sample, positive sample. To classify, this is 2-dimensional data. There is no as such a line available by which you can separate either positive or negative. You require either circle or either some other shape by which you can separate that data called non-linearly separable. Linearly separable, if 2D you are able to draw the equation of line by which you can able to separate the data called linearly separable data. If it is in 3D, 2D plane. If it is n dimension data, n-1 dimension plane is able to separate the data, then you can get linearly separable. We can convert this data into linearly separable, but we have to increase the dimension. We can project this data into 2 dimension to 3 dimension, and that example I will have. You see that this example, this is 2-dimension data, and you can draw any equation of line, either this. It depends on which model you are using. You will have variety of data, variety of models, but this is linearly separable data. Below this line you have minus samples, and above this one is positive samples. Okay. From here you can also see which feature is important for me. X1 and X2. Many times some features will not contribute at all. Okay, so you see that here my data is distributed uniformly along x-axis, y-axis, X1 or X2. Then we will consider that both having weighted X1 and X2. If all data is segregated around X1 axis and it is not distributed around X2 axis, that time x2 is called insignificant features and x1 is already considered significant. That time it is good to reduce your data to 2 dimension, 1 dimension. But this is linearly separable data. Now coming on this point, this is having 2 dimension data. If you draw one equation of line, this sample is going to misclassify. If I am placing line here, this sample is going to misclassify. So there is no as such, I cannot draw any line which can separate this data. I require at least 1, 2 and 3 or either some column. So this data is considered as non-linearly separable data. The example is jaw gate. Jaw gate with the single hidden layer of neurons which cannot separate. Okay. So neural network is especially helpful to plot the equation of line. Now you see that the data is 1 dimension. If you are plotting dot here, so this data is going to misclassify. If I am drawing dot here, this data is going to misclassify. This data is again what? Non-linearly separable in 1 dimension. Those, if I can put this kind of graph, the data will be able to separate them. Okay. So what I can do, I can project this data into 2 dimensions. Earlier you have only x-axis. Now I have used x and x square axis. So the negative value will become the positive in case of x square. So what happens? This is your x and this is becoming x square. Now, if it is -1, it is becoming 1. If it is -1, it is becoming 1. And if it is -4, it is going to 4, 4. So almost the magnitude is increased and now you can draw one equation of line. So now the data which was earlier non-separable, linearly separable, are converted into 2 dimension plane and make it linearly separable. Why I am going for linearly separable? Because you can learn easily linearly separable. Human being as well as machine. Because if there is too complexity over model, if I will give you 100 Chinese ways to identify, you require at least 100 days of training. If I will give Indian base, you can easily identify because there is no much similarity over the basic data. Similarly, machine will also get confused. Okay, that's why. Because we have distinguished features. So now in first case, we have projected into 2 dimensions. Second case, also we have projected. So we have used the function by which you can map the data. Here I have used x square. So x was already there, x square is there. In this case, even odd, even odd. So all the odd data is mapped with the 0, even data is mapped with the 1. We'll come back and then we'll finish my discussion. I had separate PPT for decision. This is a case of another machine learning algorithm, support vector machine. And support vector machine will try to design the hyperplane which will having the maximum distance from the both classes. Okay, this is called support vector which is coming in the boundary, and we try to find that hyperplane or equation of line in 2D which can having maximum distance between both classes. In case of perceptron or neural network, so neural network used to learn like this way, as we used to update weight, always you see that weight update through gradient descent. So finally we are able to achieve this equation of line which is separating data perfectly. Initially it was not able to perfectly guess, we can see that gradually it is learning, and finally it is able to classify data, and the equation which it has drawn for separating is this one. And this is not better predictor. What will happen after some time, the trend of this data is coming there. For new sample, the misclassification will be there. That's why we used to go for SVM. SVM will give you better predictor which will divide equal half of the data. But neural network will just give you some method by which you can separate the data, but that is not accurate measurement. So it is like initially the weight, you will keep updating your weights. This already I discussed. one example I am taking also classification. Okay, after that I will take for regression example. If the income is more, saving is also more. If income is more, saving is less, you are in high risk area. Company will not give you loan. Like this area is considered low risk area because income is more and saving is more. Saving is more, income is less, that is also not considered good. Income more, saving less, you are considering high risk. So you have to draw some decision boundary by which you can separate out the data. Okay, there is two class of data, low risk and high risk. So you can decide that above than this income and above than this saving, we consider that. Now coming on regression example, and the example is considered as car price. As mileage is increasing, the car price is less. Okay, as mileage is less, because this is costly car, mileage will be more less. Okay. So what is happening? You can put the equation of line, you can put the x square curve, you can put the 5 order of polynomials, HI given. You can map. If you are putting equation of line, you see that this is almost error with all data samples. If you aggregate, take the average of all errors, this is called total error. You can go for mean square error, that is square of error, so that negative and positive should not get cancelled out, and you have over your model, which model you have designed, you should have over impression of all the errors. Okay, how much error it is going to be. You can take, suppose you are coming from Bangalore to Hubli or here, Mysore. The train is getting late here by 10 minutes, here 20 minutes, here I have arrived 20 minutes before, 30 minutes before. So when I will reach Mysore, what will be my prediction? Those actual time it is taking 4 hours, maybe I can reach in 5 or 6 hours. So running trial status, when you have to see your seating status, what is the chance of getting confirmation of your seat? That time you use to prepare regression model. From here you can use prediction. So this is when you are getting their value outputs. Now coming on this point, that is very important. You have two dimensions x1 and x2, and you see that if you project all data point over x1, you will get this value and this one. So you see that both are contributing equal, both dimensions x1 and x2. Here you cannot ignore x1 and x2. This data sample is what? We have the objective of dimension is there. We have to select such dimension where maximum data is spread and distributed across. In this case, you see that there is x1, there is x2. If you take the projection, all the data will lie in this range. Similarly, y-axis you are getting same. So both are almost playing the equal roles. You have generated the third dimension, which is diagonally through principal component analysis. Here data is maximum spread. So in this case, E1 is better than x1 and x2. But many times you will get sample like this is okay. This I am not going to discuss. Okay, here is no samples. If I can write, I can write it. If data is scattered like this, okay, this is my x-axis, my whole data point are so, and these data points, I consider this oval shape. This is suppose my data points, okay? If you project this data over this plane, x1, you will find the variance almost, if you make the Gaussian plot, you will find this much variance. If you are plotting over this one, you will find very skewed plots. In data is less spread around x2 axis compared to x1. In this case, x2 is not important. x1 is important. Similar fashion, principal component analysis used to work and used to decide for which direction we have to select. Okay. Similarly, you can have example like this. If maximum data is distributed around this. Okay. So in this case, if you plot Gaussian plot here, you will find the spread of the data is around this one, and x1 axis very skewed curve we are getting. So data is spread more around X2, so X2 is important. But in this case, what is happening? Second case, if you project data over here, you are getting this distribution. Sorry. And similarly, same distribution you are getting over here. So both directions you are getting same distribution of data. That's why both are equally important dimension. Okay. And we are further investigating which dimension maximum data is spread. We find through eigenvalue. Eigenvalue will give the direction. The high eigenvalue will give such direction where you have maximum spread. So this third dimension we have considered. Okay, this was all about for machine learning presentation. So let us conclude. I started with the initial introduction of speech and signal and sensors. Then we dive into the machine learning where we have seen about supervised and unsupervised learning, then labeled and unlabeled data. After that, we have seen that how to select the model. So model selection is very important because overfitting and underfitting issue was there. Then we have seen that how to evaluate the model, what are the performance metrics. We have seen that accuracy, then imbalance data set, then precision, recall, app store, sensitivity, specificity, and finally we have seen that the dimension of data also, which direction of data is important. So if any questions, we can take question and for further discussion. This is all about presentation. If any specific set of questions, I can take. Okay, fine, and there is no more question, so we stop here. Conclude here.